Hello? Hello? Oh, okay, awesome. Hello, everybody. I guess we'll go ahead and get started here. So thank you for coming out to another OWASP Toronto chapter meetup. My name is Adam, and I'll be your host for this evening. I'm very excited to present Critique here. Before we begin, a couple of housekeeping items. For one, where are the washrooms?
The washrooms are outside. There's a paper with the clothes in the washroom.
All right, look for that then. And is anyone in the audience hiring? No, okay, that's rare. That's what it is. If you're looking for CVE credits, you can feel free to reach out to myself, Ophir, and the other OWASP member teams. If there's nothing else, Carl, do you guys want to say anything?
No.
Yeah. Yeah, thank you guys for having us. And Critique, you ready? Awesome. Well, give it away for Critique.
Thank you very much, everyone, for taking the time to come to this talk. My name is Critique, and the name of the talk is Inference Servers, New Technology, Same Old Security Flaws. So yeah, we're going to talk about a lot of different stuff. I'm going to talk a lot of different stuff, so I'll just go ahead and get started. First, this did work.
Too many people in the room have to leave. Should I move ahead? Do you want me to move ahead?
Yeah, I just this.
Move ahead when you want me.
Oh, it's because it's not on there. Sorry. It's because.
Oh, okay.
Yeah.
Okay, sorry about that. Okay, so yeah, a bit about me. My name is Critique. I'm a principal security consultant here at Cole. I've been in different sorts of AppSec stuff for the last 15 years, a bunch of different consulting, things like that. A lot of the stuff that I'm going to be talking about in this presentation is stuff that came from work directly with clients. There's just kind of a lot of technology that we came across in this presentation, but stuff that we tested with our clients and kind of finding a bit more while we were doing different sorts of projects. And kind of some cool workabilities, especially with help. In terms of like my specific AI stuff, I'm not really like an AI advocate. I'm not here to tell you it's going to change the world or your life or anything like that. I'm kind of just here to talk about capabilities, so hopefully some cool stuff. So in this presentation, I'm going to be talking about a few different things. I'm going to start off by talking, giving you a bit of an introduction to what models are and how they work. We'll go through some examples of how to actually use them. It's actually pretty straightforward and not complicated at all. We'll talk a bit about PyTorch pickles, different file formats, and we'll talk about some security vulnerabilities that are kind of inherent in some of these file formats. Then once we kind of set that ground level base work, I'll talk a bit about Inference Servers, what they are, how they work, and we'll dig into some vulnerabilities that come along with them. And then we'll have some security vulnerabilities and external security concerns with things like TorchServe and some other servers. So starting off, just a bit of an introduction to machine learning models. What are they? What do they do? And how they work. So what is a model? At a pretty base level, a model is basically just a program that is programmed to return a prediction to you based off of some sort of input and the data that it's been trained with. Typically, models are created using the deep learning library, something like PyTorch or TensorFlow or something like this. And these libraries have different sorts of. Can you guys hear me at the back of the call? Yeah. Yep. So yeah, PyTorch and TensorFlow have different sorts of libraries that use training models, use them, and do different things with them to kind of have a bunch of functionality in and along those lines. And models are trained using patterns of data. So basically, you probably heard of training the models using data. How that works is you basically feed the model using PyTorch and library kind of structured data. The model parses it. Yeah, so models are basically trained using patterns of previously analyzed data. Once a model has been trained, you can use it by providing it some input that it's never seen before, and the model will return a response to you. A response to your prediction. So it basically uses the input that you sent in, the data that it's been trained with, and returns a prediction. The act of using a model to do this is called inference. So that's the inference part of Inference Servers. It's basically, you'll use this, you'll hear this term quite a lot if you look at models and LLMs and things like this. You need to know all this as a security person. You need to know how models work at kind of a deep level. I would say that you don't really. There are some things that I think are really important, from specifically a security context. The one that I personally was a bit of a glass-shattering moment for me was coming to terms with the fact that at the end of the day, models are files. They're files that exist on the file system. They can be moved around, copied, shared, used however you would in a normal file. So using a library like PyTorch, you can save a model once you've done trained it, save it, it becomes a file system. You can also load it using commands like torch, upload, or PyTorch. And so in a lot of ways, loading a model is conceptually similar to executing a binary. And as a security person, you might have a lot of threat models or security considerations that come along with running an arbitrary binary. It's kind of the same thing when you're talking about models. And from a security point of view, there are a lot of kind of security concerns. Models come in dangerous file formats. One of the ones we talked about, it's kind of inherently dangerous and can be abused pretty easily. Models also have a bunch of supporting code that kind of is pushed along with the model, things like tokenizers or handler files, which can be arbitrary code. Models are also really easy to share. Anybody can download models, you can share them, download them. It's pretty straightforward and it's a pretty open ecosystem. And the one thing that I'll kind of talk about throughout this presentation is that the point at which a model is loaded into memory is a very important security context. And that's the point where you can have a lot of issues. So I'll start off by walking through an example of how to use a model. It's actually quite a bit easier than I'm thinking. I'm going to be talking about a tool called Hugging Face. You might have heard of this, you might have never heard of it. It's basically like a GitHub for models. You can just browse to it, you can see quite a lot of free open source models that you can use. You can see in the screenshot here that there's almost 1 million models here. Hugging Face has models that do a lot of different things. So you can do text generation, so something like ChatGPT, where you're giving it an input and a prompt, you're getting a bunch of text that's generated back. You can use it for image generation, text classification. You can see a bunch of different categories here. Depending whatever you want to do, you can probably find a model of Hugging Face that supports it. Hugging Face also supports a bunch of different platforms, so it supports PyTorch, TensorFlow, a bunch of different things. And yeah, it's pretty easy to use. The other key part of Hugging Face is that it supports a library called Transformers. Transformers is really widely used, and if you ever looked at like a modern AI application, there's a pretty good chance it's using Transformers under the hood, unless it's using like OpenAI or something. And basically, what Transformers does is it provides you a bunch of auto magic functions that you use a model in a couple lines of code. Basically, just use one function call, download, execute a model, pass input into it. Very easy. One kind of key thing to think about when we're talking about Transformers is that at the end of the day, Transformers is just launching a backend. PyTorch and TensorFlow to actually load and run the model. And it's kind of doing its actions. So as an example, I'm going to talk about a model called reverse spam. I like talking about this one just because it's quite simple. It's very small and it's easy to explain. So reverse spam is a text classification model. And the purpose of this model is that it accepts text of some sort and it classifies it into one of two categories. It either thinks it's spam or it thinks it's safe. So you would use this to, like, let's say, classify a bunch of input messages to see if it's spam or if it's hacked. This model accepts a tokenized string as input. So I'm not going to talk too much about tokenization in this presentation, but the gist of it basically is when you interact with a model, even if you're sending it a sentence, you're not sending it like a sentence as in A, B, C, D. You're sending it a list of tokens in the form of something called a tensor. And so you need to tokenize your input before it's in the model in order for the model to understand it. Transformers kind of matches away a lot of that functionality, so you don't have to think about it. This model just accepts some input. This model also responds with a output tensor, so it's a two-value array. Basically, the first element of the array is span or sig, and the second value of the input is I think somebody. So how does this look like? So if you look on the right side here, this is just a download page for the interface for this model. The red square that I have highlighted, those are the two model files. They're both the same file, just in two different file formats. One of them being a safe tensors model, and the other one being a PyTorch model. I'll talk a bit about what the differences are between those two. So how does this work? This is using transformers to use this model. There's a lot of stuff on the screen, so I'm going to go through it kind of one by one. This is probably the most complicated part of this presentation. So at the beginning, I just have a folder. This is some Linux. I have a folder. It's two files in it. One of them is called config.json. The other one is PyTorch_model.bin. This is the actual model file. This is the PyTorch version of that model. The next section, so I have some Python code, which is using the transformers library. This line is the line that's actually loading the model. And so again, transformers has a bunch of kind of magic functions that load the model in. So this is auto model for sequence classification. I'm just passing in the folder that I listed before, and then this is loading the model in from that folder in order to be used. Under the hood, this line is calling torch.load on that model file. This is the PyTorch model. So that's how it's actually loading the model to be executed. This section is the tokenizer. So like I mentioned, when we talk to the model, we need to tokenize the input, so it's not just in this case, this is another auto function transformers. So I'm just loading it in kind of as by itself. But I'm taking the sentence, which is your card has been hacked, go to evil.com, and then I'm just tokenizing it. This line here is just taking the tokenized input that I have and then sending it to the model. So this is the model's already loaded into memory, and now I'm pushing it to send it to the model. So that's actually using the model. This is the output of the model. And you might look at this and be confused. This is a very confusing output. This value here is the output tensor. And the output tensor is, like I mentioned, a two-value array, which has some numbers in it, which might look a bit confusing. But if you remember from the previous, I think there's some more frozen. If you remember from the previous slide, the expected output for this output tensor is a two-value output array, with the first value being safe, and the second one being spam. And these two values, you can see that the value for safe is a super low number, the value for spam is a super high number. And so basically what this model output is saying is that it thinks that the sentence, your card is hacked, go to you.com is spam, which is more or less correct. Now, there's things you can do to clean up that output, but that's basically on a very high level how the model works. So that's just a bit of a baseline setting, so that some of the rest of this stuff makes a bit more sense to you. The next thing I want to talk about is PyTorch triggers and kind of how they work and why they're dangerous. So PyTorch models by default are Python pickles. If you aren't familiar with what a Python pickle is, basically a pickle is a series of serialized Python instructions. So when a Python interpreter sees a pickle, it just basically executes the instruction that is needed. Apparently, this is very unsafe. You shouldn't be unpickling data if you don't trust. If you go to the Python documentation for the pickle module, there's a big red warning at the top that tells you it's not secure, only unpickle data that you trust. In the previous slide, when I did that auto model load thing, it was pickling, unpickling that model file that I just downloaded off the case. So it's very dangerous. This is just how PyTorch models are. If you've done any sort of looking into this case, this is like risk and threat number one. If you're using PyTorch, is that by default, model files are basically just serialized instructions. You shouldn't be loading them in without some kind of guardrails in place. What this also means is if you're a security person and you're looking at code for something that is using PyTorch, if you see the user input that's passed into torch.load, it leads to an exclusion. It's basically in a lot of ways the same as having an eval statement where you're having a output that goes in there. If you control that output, you can push a malicious pickle and get your execution. There is a new parameter in PyTorch called waits only. This is not enabled by default yet. When it is enabled, it's basically a restrictive on pickler, which means that we can pass input into torch.load and have it only enable state parts. That's basically something that is enabled by default right now. So this is an example of that working. I think some of the text might be a bit hard to see here on this projector, but basically at the top here, I have some Python code, which just creates a malicious pickle. So this is importing the pickle library. It's making a command, which is cat password, and it's passing it into the use function. It's not super important. Basically, the gist of this is that this creates an output file called payload2.pickle, which is a pickle that has the instructions of cat password. And then in this bottom part here, I'm doing import torch, so loading the PyTorch library, and then doing torch.load payload2.pkl, and then you can see at the bottom the output of cat password points. This is a really basic example again. If you are using torch.load on some object and it's a pickle, it's going to. So that's one way of using torch.load. The other way, which is underlying the same thing, it's called pickle. The other way is you can take a model that works, so kind of a fully functional model, and you can just unzip it and change one of the internal files. So here I have the Roberta spam file, which again is the one I downloaded off the Hugging Face. If you unzip this file, if you unzip this file, there's a bunch of different files in there, including some detail files. I'm using a library called Picking. Picking is a tool that was created by TorchServe. Kind of the purpose of this file, this tool is to let you do a lot of cool things with pickles. You can inject code into them, you can evaluate them, read them, stuff like that. That's what Picking does. So what I'm doing here is I'm unzip the file, and I have a pickle file, and I'm using Picking to print just a statement called print injected code into the file, and then I just re-zip it up, so it's just this file again, and then you can see here at the bottom, I do import torch, torch.load, this new file that I just created. The rest of the model loads, so the functions load, but at the beginning, the injected code I have also executes. Neither of these are super groundbreaking. This is kind of just how this works. The pickle file uses no execution. It's pretty straightforward. I'll talk about a few different file formats before I move on to Inference Servers. The first one is called TorchScript. So TorchScript is a different model format that PyTorch supports. It is a optimized version of a PyTorch model. Basically what that means is that in their documentation they say that TorchScript models, TorchScript code can run on any Python interpreter, but not Python code can run on TorchScript. So this is because TorchScript has significantly less built-ins and functions that it supports. So what that means in practice is, even though this looks like a pickle, if you unzip it, you see a bunch of PKL files. It's not the same type of pickle that Python pickle is. So at the bottom right, you can see if I use torch.chip.load, which is how you load a TorchScript model, even though I have the same payload, the error says unknown type name built-ins.eval, because the built-ins.eval command doesn't exist in the context of TorchScript. So this isn't as exploitable as just using a PyTorch model. So if you're using TorchScript models, you're more restricted to the functions that exist within TorchScript. And this is mostly math-related functions. So you might be able to use it. I haven't personally had a lot of them. TensorFlow is another model language library. This one's by Google. It's a completely different format. It doesn't use pickles. It's kind of totally different. There is some code execution vulnerabilities that exist depending on the type of model format that you're using, how it's outputted, and how it's consumed. I haven't done a lot of research with this, so I won't talk too much in it, but if you're interested, there's a lot of really good research from somebody in Connor who talks about this. I'll leave it there for that. The last file format I want to talk about is called safe tensors. So safe tensors, you might have noticed in the Hugging Face thing, two file types are PyTorch models and safe tensors. Safe tensors are a file model file format from Hugging Face. It's the one that they publish, it's the one they tell people to use. It's very limited in what it can do. It's fairly simple, but it's also safe. It's been audited by a bunch of people. And if you can use pick a model format for your models, yeah, you should be using safe ones. You should be using dangerous model format. So with all of that said, I can finally talk about Inference Servers. So what is an Inference Server? An Inference Server is basically a front end for a set of models. It exposes a set of APIs, usually through RESTful APIs or gRPC APIs, that lets you use a model. So it lets you pass input to a model and obtain the prediction that you're getting back to the model. If you've ever used like OpenAI's chat completions API or Bedrock or something, when you send input, you're sending input to some API and then you're getting a response back from the server. Conceptually, that's an inference server. We don't really know, of course, how these cloud providers actually implement these endpoints, but you're performing inference through an API server. So this just lets you do it yourself. So if you have models you want to host yourself, you can host them within the context of the server and then have them be accessible through some APIs. The dangerous thing is that they also export APIs that allow for model management and kind of metadata operations. And these are the ones that can generally be abused for code execution. You might wonder why you might use an inference server locally. One of the reasons is that cloud-based API providers are pretty expensive. You're paying for tokens, you're paying for a few times stuff. If you're hosting it yourself, you can, in theory, save a lot of money. The next generation of the Llama model that Facebook is releasing is supposed to be pretty comparable to the current that's going to be on Hugging Face or older version of Llama around Hugging Face. You can already, make a pretty good case for hosting your models currently, and that's probably going to get better as time goes on. And then from an architectural perspective, if you have models within your environment and you need to kind of distribute them and use them, you don't want to necessarily be hosting the models on every single server. You might want to have one central place, let's say a central database server. It's kind of some of the reasons. Who knows? Maybe this doesn't really catch on. It's all kind of new stuff. So TorchServe. TorchServe is the model serving component of PyTorch. So it's a sub-product of PyTorch. It is maintained by a combination of AWS and Meta. So they both have a shared sense of ownership, responsibility with it. If you look at the docs for TorchServe, it kind of goes over a bit of the places that it's used. So it's used in SageMaker, Cortex AI, a bunch of other places, kind of as an internal component to serve and expose models for use. It supports LLMs, like larger models you have used through TorchServe, kind of as a component in a few places. It also uses a model archive format called MAR, which is pretty similar to a WAR file, if you remember that from Tomcat. A lot of the abilities we'll talk about are very reminiscent of that. So using TorchServe, this is just kind of an example. At the top here, I have the model weights for SqueezeNet. SqueezeNet's a pretty old model. It's one of these examples, so it's the one I've used. SqueezeNet, it basically is an image classification model. It's not super much we know. Basically, it takes in an image of some sort and it returns you what category it's in. And the file that I'm downloading there, this is a PyTorch tree, so this is a PyTorch model. Then you need to convert that into a model archive file, an MAR file. And TorchServe has a binary file that lets you do this. It's called Torch Model Archiver. A bunch of different parameters here. The first two, model name and version, this is just naming the model version. So super important. The next one is called model file. This is the Python code, which handles the incoming requests. So it's basically a handler file or something. So if you need to do any sort of tokenization or transformation, this is the Python file that will do that. The serialized file is the model weights. So this is the binary weights that downloaded at the top. Last one is just a handler. So this is the name of the function that is executed when the model, when this kind of token executes. So once we've made the MAR file, when you run the last command, the output is an MAR file. To launch TorchServe, all you do is you make a folder called model store, you put the MAR file inside the model store folder, and then you start TorchServe. So you just do --start and pass in some parameters. And then you can use an API call to make the bottom here. I have just Perl to localhost support 8080, which is TorchServe support. Sending in a photo of a cat or a kitten, and the response from the server. The response from the server is the response from the as you can see here, it's the model is, it thinks that the image is these 5 categories. So these is happy. So with all that kind of being said, what are some security concerns in TorchServe? The first one is service exposure. So when you launch TorchServe for the first time, it launches 5 different ports, which is kind of crazy. It's kind of a bit of a remnant of people, in my opinion. You typically don't see as many ports. So it launches 2 RESTful API ports. The first one on 8080 is the Inference Server. So this is the API that lets you use the model to perform inference. It also exposes a management API server on port 8081. This is the port that's used for some of the dangerous operations I will talk about. Then there's 2 different versions of those APIs. It's just on gRPC. So gRPC, if you're not familiar, is just a different request protocols, binary rule, and then it launched some metrics. So earlier versions of TorchServe had all of these interfaces by default bound to all interfaces. And that's an extremely common design pattern as in practice, if you're using this product within your organization, you will likely need to expose this for somewhere. Right? So that's something you is that somebody's using TorchServe, you have some kind of exposure that's multiple versions of these APIs can lead to some configurations. The first one is one of the things that we reported TorchServe to fix. So this one is CVEs. I'll fully admit this is a bit silly, and my first kind of reaction to this is kind of whatever. When you read the documentation, it says that all databases are supposed to be bound to localhost, but the 2 gRPC ones aren't. So if you launch them, they are bound to all interfaces. So my first reaction is, it's the documentation discrepancy, not really a big deal. But this is actually quite impactful for a lot of reasons, and the main one is because there's no authentication. Prior to the latest version of TorchServe, TorchServe didn't implement any auth-end on any of the APIs. So what that meant is if you could talk to the inference port, you can perform inference on any model that's running. If you can talk to the model management port, you can load and unload models, do a bunch of dangerous stuff. This kind of log here, this is kind of what they said, this is similar to all the other inference servers. Basically, you're saying it's your responsibility to secure it, it's your responsibility to restore ports. To be fair to TorchServe, after we reported the previous issue and some other things, they did actually change it, and as of now, I think they're the only inference server that by default enforces authorization. So they enforce authorization, they also disable by default the most dangerous API, which I'll talk about in a few slides. That's good, and the team at AWS actually was super nice, and they were super effective in making these changes. This lack of authentication is very common. Other inference servers that are kind of popular, TensorFlow Serving, which is by Google, Triton Inference Server, which is by NVIDIA, both by default have no authentication. They both also bind all their interfaces to all interfaces. So that means if you launch it on a host, any those ports can, without any authentication, call these things. It's pretty crazy. This is kind of legacy stuff. This is what used to happen 10 years ago. Not so much these days. If you're wondering why these servers are kind of designed like this, generally reading the documentation, I've come across 2 specific things. One is that when we're talking about invoking models, so if you're running models on GPUs, there is a legitimate concern around performance that people have raised. If I have to evaluate an authorization header and every request, that will be time I need to evaluate the request, which is going to be a problem. I don't know how much I really believe that, but it's understandable. The other one is that it's your responsibility to deploy this in a secure way. This is supposed to be an internal component. You shouldn't expose the APIs. But that puts a lot of pressure on people who are deploying it, people who are responsible for the security of these products, to know what these APIs do and kind of what they can use for. The biggest problem with these APIs is that you can, generally speaking, get code execution if you can call the model management. So on a TorchServe on the model mapping API, there's one specific API that's quite dangerous. This is the register model API. This lets you load in a new model to use files. And you probably think of how this can be used. There's actually quite a few ways this can be used. This API takes in a URL parameter, takes two possible arguments. The URL can point to a local file, this for to deploy, or it can point to a URL on the internet to download it. The target has to be an AR file, so the model archive file we made before. It copies the model archive file into the model store, and then it invokes the model. And so this can be pretty quickly used for conversation. The first way this can be used is, if you remember the command we made to generate the model file, or the model archive file, there is a model file parameter. This just points to a Python file. This is the file that's used to handle requests and used to tokenize things. But this can just be any arbitrary Python file. So you can put it in whatever payload you want, anything in here, and when you perform inference on the model after it's been loaded, this Python code has to. So that looks something like this. So if I take the model archive file and I just add in a subprocess.run, add a password command, I use this modified file to generate a new AR file. So I use TorchServe archive to generate a new model file. And at the bottom here, maybe you're able to see it there, but I'm just making a curl request to the /models endpoint. I'm passing in a URL where I just uploaded this AR file. And then we say an initial amount of workers. You can see at the bottom that this malicious AR file gets deployed. There won't be any code execution yet. The code execution will happen when you try to use this model for prediction. So this is making a inference request to that model that's asking for what we have. And if you look at the service logs, you can see kind of hard to see there, but you can see the output of cache. So this is just running a Python file when you perform it. That's kind of the purpose of that model. The second way to do code execution is the serialized file. So this is again a PyTorch model. So this is the main one. So again, similar to what we did at the beginning of the presentation, you can just put in whatever you want here. This file is loaded eventually using the torch.load parameter. So that looks something like this. So you just download this user model, we did it before, unzip it. Again, we're using picking to inject some code into this, repackaging it up so it's used. That's good. Creating a new model archive file with this new malicious pickle file, and then using the curl command at the top again, making a request to the additional models API. There's no authentication. This execution happens as soon as you send this request. As soon as you send this request, that model is loaded into a torch.load, and then the malicious contents in the table. So these are two different ways to get code execution. The underlying reason is that kind of the purpose of the register models that you have is that you can send in a malicious model and load that. Similar to how like Tomcat used to work. There are some restrictions that TorchServe allows you to set. One of them is this parameter, which you can set at launch. It's called allow URLs. This basically sets an allow list of accepted values to allow model loading from. You can pass in a file or an HTTPS URL, and it will limit it to that location. And we did find a kind of funny issue in this. The screenshots of the parts here. But basically, the gist of it is if the URL parameter contains the path traversal payload, so // TorchServe can respond with you with inherit the relative path. However, you would do this after it downloaded the file. So download the file, turn it on. But since it's downloaded, now you can just reference it with the path and execute. So you can't really see anything like that, but if you actually look at the code, literally all they did is fix it. They moved here, move that check like 2 lines up. Kind of funny. This fix, it's kind of what that would look like if you had an allow URLs parameter that just said only allow files from /m. You look at your model store, there's just your normal AR file in there. Then you try to load your attacker.r file using /////. The error says relative path not allowed, but then if you look at the model store file folder, your file's in there, and then since you can reference anything in the model store without needing to provide the path, you just reference the attacker.r and then So yeah, that was, the last couple slides, I'm going to talk about two of the other servers and some basic across. The first one's called Triton. Triton's by NVIDIA. NVIDIA is obviously a huge player in AI and models and stuff like this. This is their server. I have seen Triton used a lot. It's quite popular. They also recently have a few partnerships with ELN, which is very popular. I've seen used in a bunch of places. So Triton exposes both HTTP, CVEs, similarly to TorchServe, and similarly they have the top by default and they're bound to all interfaces. You can also use cloud-based repositories for Triton. So what that means is instead of the models being on a file system, they can be an S3 bucket.
We just have a question from a streamer here. Is there a way to allow arbitrary models to check them for bad behavior before the file is actually registered?
In TorchServe, no. But I think it's quite dangerous. Like I don't think you could, it would be similar to like if you're allowing like a bash script, how you want to check this much. There's a lot of gray area before the risky. So yeah, the it supports cloud-based repositories, and it also has model management APIs that can be used. So for Triton, Triton has 3 different model management modes. By default, the mode is none, which is the good one. None means that it will only use the models that are there when you launch. You can't change it without restarting the server. It's good. You should keep it at that. Whole is the kind of medium tier option. What Whole does is it will constantly look on a disk for new models and it sees that it will try and pull them. So that's fine unless somebody can write to the location where the models are. So they can do that, then it will load the model in and run for the. The third one is explicit. So this basically what this does is it exposes this API and B2 repository model is fine. This can probably just be should be placed. This is a feature, not necessarily security vulnerability. So you can see here on the right, I have model control model essentially explicit. Then service launches, there's 3 different ports, all on 0.0.0.0 standard, and then I'm seeing the model that's loaded, output of added to custom. New model loaded next to it. How this works is with like this. This model, this API is really confusing to me if you want to actually get started. Most of it is not really that important. The key thing here is that the backend parameter, if you set that to Python, it will try to load a Python model. And what that's actually doing is it's trying to run the command Python model.py in the folder that it creates. So if you can control the contents of model.py, you can just run that. This API very conveniently also allows you to just write an arbitrary files to this folder. So the bottom here is just file, and that's the basis for that we're sending. And so the combination of these 2 things just has fun. So that model.py file is just the basis for it. So there's one restriction you need, which is that Python code has to reference a class called Python model. The class doesn't have to be anything, it just has to be a model. And apart from that, if you call this API, the last thing I'll talk about is TensorFlow Server. This is Google. I don't know how this is used. It's still getting updates, but it's kind of hard. Google. This is a completely different kind of model format. TensorFlow models, not PyTorch models. But again, 2 different interfaces. There's no authentication by default. There isn't as much super crazy APIs. There's this one that I did find, which is only on the gRPC APIs. This isn't one of the RESTful ones. It will handle reload configure requests. This API call lets you load a model from this. It will also overwrite the previous config. So even if you can't location of this, you can just force it to just point to an application and service just keep loading this. The models here, again, are not PyTorch models. They have to be TensorFlow state format, which you can get code execution with, and I haven't much success. So this is kind of just balance. Like this is really cool called gRPC cron to make gRPC requests. And this is calling this specific proto, which is handle reload config requests. And then the important parameter here is base path. That's the path on this that it will try to load now. And then you don't want from this API, it is bound to all interfaces, so unless you're explicitly blocking it somehow, if this is launched, you do this. Some of these, at the bottom, you can see that the model loads. In this case, the workspace the model existed, but if it had a path that didn't exist, you would just keep moving around. Yeah. What should you do with all this information? As an attacker, if you're doing assessment, you're kind of security something. If you see some of models being loaded and unloaded, that's a very important security point. It's very dangerous. So any kind of authentication control, validation control are really valuable. Being able to write to locations on this, the models being loaded can inherently be very suspicious. Specifically, if you're looking at it in PyTorch, even if you just like run for torch.load and see where that input's coming from, that is in a lot of ways the same as like well statement. It's loading the model with that, and you can control input, you can get research. As a defender, you should use safe model format, so safe answers by far is the one that people should use. If you're using any of these Inference servers or anything really, they use models, you should be aware of the network exposure of these services and what ports are aligned to all these ports. Is there any application on these ports? Very important. A lot of these API services or Inference servers also allow you to disable features in your ports. So by default, you should do that. If you are going to use them, you should be exposed to it. Yeah, the last thing really is just reading the documentation. Almost all this stuff I found just written out in the documentation. All these things are vulnerabilities per se, they're just features, they're tools. You can obviously use that's for me.
How does G
Sorry.
GG
Oh, yeah, I haven't. So the thing with safe answers is that it's like whole equals a very small. People are really too much about this. I think I have seen some information on that. But it's, you know, it's kind of hard to say.
For the remote code execution in TorchServe, is it only with the RESTful API, or have you also looked at the service?
So the TorchServe applications.
Okay.
Any other?
Yeah, so you mentioned that Google and NVIDIA have no authentication on their APIs. Does their documentation warn at all that this is insecure?
So in both cases, the documentation basically just says like, you know, I think in both cases it says this is supposed to be internal, you shouldn't deploy this anywhere. They basically just put it all on you. I think specifically, they want you to deploy something, which is probably how a lot of people are using it. But like some of these things, if you don't deploy it in a container, it's like very almost. They acknowledge that these are security flaws, but they kind of just it's not.
I experienced a lot of those popular economic research has a lot of the same problems in my experience.
So it didn't. I was actually trying to find like other servers. It's like a weird thing where like I feel like it's a bit of like old new technology where like I did it. I was actively trying to find. Any other?
First of all, my sitting at media gigs, I do question many conventions on the boardrooms, but that's based upon the fact that only 10 to 50% of firms have kind of wrapped their heads around this issue as far as policy, and there's a big wave of stuff coming along. How large do you think the backlog work would be? And again, like, a lot of people don't understand what they're doing.
I would say that like, based on my experience, most large companies who use this kind of stuff are still using providers. So they're not doing this stuff themselves, they're kind of like using OpenAI or Bedrock. And in that case, you're kind of offloading more of this risk to the providers. I think if it still ends up growing, and like at some point, people are going to develop their own their request, and we can just do this internally. Then I think there's, like that's user risk that you consider right now, unless you're doing it, really. We also select obviously specific models. Like hugging cases is kind of crazy because you use them, and I guess in organization you might have a lot of controls around things like third-party packages or something, or like tools and stuff that people can run on the platform. Yeah, I think I would actually work for so like somebody downloads like a model hugging case and runs it, which is code. That's probably going to become some tool, but like that's kind of vision of other initiatives. It's just kind of complicated. Any other questions? Very much.
All right, well, thank you all for coming out. Thank you, Steve, for giving an awesome presentation. And thank you, Kroll, for hosting us. Always a pleasure to see you guys. Yeah, that's right. And yeah, thank you all for coming. Have a great Halloween, and we'll see you next time.
Yeah, very quick question. So, I work with a company called TorchServe. So, my company lets me upload their own models.
Okay.
And
That's very scary.
yeah, so, we haven't thought of safety so far it has to do. I mean, it's still in progress. It's halfway through development. How do you tackle this problem?
Do you let them upload any type of model?
Yeah, that's the near future. But I mean, it's going to be still in containers and it's going to be one organization, one user. It's a single tenant model.
I think it's like one container per model. You can maybe just like have a different model that way, but it's still very I think like you specifically don't allow PyTorch models. The rest of it you can kind of work on.
Okay, because the whole product itself, it's a database